Okay, like I said in the last video, we're going to talk about solubility now, and I've got the definition written down for you here. Solubility tells how much solute can be dissolved in a specific amount of solvent, okay? So that's usually given to us in a certain number of grams of solute per 100 grams of solvent. So as an example, if you have 100 grams of water, right, that's your solvent, this and the solute is salt, you can put 35.9 grams of salt at room temperature into 100 grams of water. That's how much solute, how much salt will dissolve in 100 grams of water. You can't put more than that. If you hit that point, if you try to put more than 35.9 grams, it's just not going to dissolve. You can stir and stir and stir, it's not going to dissolve. What we call that when a solution has hit its max amount of solute, that is a saturated solution. So once you have a saturated solution, you're not going to be able to get more solute in there. So solution with max amount of solute. All right, you're not going to get any more in there if conditions stay the same. Let me say it that way. Okay, so there are some things that affect solubility. And you already know this, actually. And I didn't say this in the last video, but let me make clear. When we think about making these mixtures and dissolving something into something else, we often think we're dissolving a solid into a liquid, right? Because we do that all the time, salt into water. Sugar into our sweet tea, right? It's pretty common for us to take some solid substance and dissolve it into another. I made myself an iced coffee this morning. There's this like Nescafe espresso powder, and I put that in there and mixed it into my water, right? A solid powder, and with the coffee with the ground espresso, and I mix that into my water. But you don't have to do only solids into liquids. You can actually mix gases into liquids. We're going to talk about that in just a second. That's what you have whenever you are drinking a soft drink. That soft drink has CO2, when we say carbonation, it's because it's got carbon dioxide mixed into the liquid, right? That's what makes it bubbly. So you can mix a gas into a solid, into a liquid. You can mix liquids into liquids, right? That's an option. You can even mix solids and solids together and have a mixture that way. So like if the metal alloys, what those are is that's one metal that's been dissolved into another metal. That's a solution that's been created by two solids, all right? So thinking about that and just thinking about our experience, because we do have we have some knowledge here, some things that this next section here where I'm saying the things that affect solubility. We know some things that affect solubility, right? We're already familiar with that. Again, go back to the unsweet tea option, right? Why would people have unsweetened tea? I guess living in the South, that makes no sense to me, right? But if you go to a restaurant and they're like, sorry, we only have unsweet tea, and you ask for unsweet tea and they bring you out an ice cold glass of unsweet tea and you start trying to mix your sugar into it, what's going to happen? It's not going to mix, right? That sugar is just going to sink to the bottom. And the reason why is because there are things that affect the solubility of that sugar in that liquid. Right? And what are the things that we want? What's one of the things that we know? Why won't that work? Why can't you mix the sugar into that iced unsweetened tea? Well, it's because it's so cold, right? We know that temperature affects that. If we heat that liquid up, if you have a pot, if you make tea here at the house and you put your tea on the stove and you heat it up, you steep that tea and it's hot, and then you put the sugar in, it'll mix no problem, right? So when we said in this first example here, when we can put 35.9 grams of salt in 100 grams of water, notice that's at room temperature. That value will not be the same if we change the temperature. And so our first thing that affects solubility is that the solubility of, in this, well, you know what, let's jump down to number 2, actually, because that's what we were talking about just then. The solubility of most solids, whoops, let me make that a little darker. The solubility of most solids increases. It becomes more soluble with increasing temperature, right? And of course, we're talking about the temperature of when we're trying to mix it together, the temperature of that liquid that we're mixing that solid into. The solubility of the solids increases with increasing temp, all right? So that's important that we understand that. Again, just think of mixing your sugar into your unsweetened tea. The warmer it is, the better it dissolves, the more soluble it is. Now, for gases, when we have this scenario, like I mentioned a minute ago, when you've got a gas dissolved in a liquid like you have in a carbonated drink, the solubility of gaseous solutes, actually the opposite happens. It decreases with increasing temperature. So if you take a can of your favorite soft drink and you open that up and you sit it on the counter and leave it there for 30 minutes versus sticking it in the fridge and leaving it there for 30 minutes, you're going to notice the one on the counter is going to be flatter than the one that you put in the fridge. And the reason why is because as temperature increases, gaseous solutes, their solubility decreases, all right? It's going to be easier for that gas to escape if the temperature has increased, all right? So the opposite of what we have with solids. And then finally, this last one, again, a soft drink is a good way to think about this. Whenever you have a gas dissolved into a liquid, so we're talking about the solubility of gaseous solutes in this third thing that affects solubility. You have that in that sealed can and it stays fizzy, right? And it will continue to stay fizzy. Have you ever gotten a soft drink though, and you go to pop the top on it, and it's like you don't hear that, and you're like, oh man, there must be a hole in the can, right? Well, what happened? There was a hole in the can somewhere, and what happened is that the liquid did not stay under pressure like it was before. As long as it maintains that pressure, then that gas will stay dissolved in the liquid and your soft drink is going to stay fizzy. But the solubility of gaseous solutes, so the solubility of gaseous solutes increases with increasing pressure, right? So as soon as you pop the top on that soft drink, it's a ticking time bomb at that point, right? You have released the pressure. You've decreased the pressure in that system, and you know it's just going to be a matter of time that those bubbles are going to disappear, right? The liquids, the bubbles are going to be less soluble in that liquid. They're going to escape. They're not going to stay mixed in, and your soft drink's going to get flat. So when pressure's high, the gaseous solute, the solubility of the gaseous solute will increase. Okay, hopefully that all makes sense. I think that those practical experiences that we have will help us remember those three concepts and how they affect solubility. So we're gonna go from there and talk about some concentration, right? So we talk about we can have like a certain amount of liquid will only hold so much of a solid solute, like the salt here. And if we hit a point where we have too much, it's a saturated solution and no more of that solute will mix in. But you don't have to max it out, right? You could have less salt. You could have 2 glasses of water, both the same size, same amount of water. There's a certain amount that would make the solution saturated, and 1 cup could have the full amount in there, and the other cup could have half that. And so how do we talk about that? When you've made a solution and you've got, like the one container has less than the other container. What do we call that? We know that. We call that concentration. So we will learn some ways to think about how concentrated a solution is, and we'll talk about that in the next video.